go through it. So first part said, let's write the first four non-zero and the general term for e to the x minus 1 squared. So our first term should still be a 1. Our next term, we should replace the x with an x minus 1 squared. So we'll have plus x minus 1 squared. And then we should have x minus 1 to the 4th over 2. And then we should have x minus 1 to the 6th over 6. Everybody good with the first four non-zero? Yeah. And then our general term just becomes x minus 1 to the 2n over n factorial. Easy enough there? Yeah. And that was worth 2 points. 1. Part B, we want the first four non-zero in the general term for f about x equals 1. So now we need to subtract 1. So if we subtract 1 from our series, well, that just gets rid of this first term. Right? And then if we divide everything by x minus 1 squared, then that's going to bring down the power of each of these things by 2. So our first term should become, well, x minus 1 is a 0, or just 1. Next one should just become x minus 1 squared over 2. And then x minus 1 to the 4th over 6. And then the next one would have been x minus 1 to the 6th. And it should have been 4 factorial. So that'd be 24. And then we end up with, what's our final thing here? X minus 1 to the, not to the n. Should be x minus 1 to the 2n minus 2 over n factorial, right? And that was worth no, it should still just be. Should still just be. Yeah, it should still just be 2n because no minus 2 on that because we got rid of that first term. So it was just 2n, but still n factorial. And that was worth not n factorial though, because these are now, if these are n's, these should be what? Those are n plus. This is 2n, that should be n, plus 1 factorial. That's better now. N equals 0, n equals 1, n equals 2. Yeah, that makes sense. Okay. Yeah, I think through that a little bit. Everybody good with those? X minus 1 to the 2n over n plus 1 factorial? Yeah. Okay. Cool. That was worth also 2 points, 1 for the first 4 and 1 for the general term. For part C, we're looking for the interval of convergence. So we're going to use the ratio test for our series from part B. So we're going to use the ratio test on x minus 1 to the 2n over n plus 1 factorial. So we'll do the limit as n approaches infinity of x minus 1 to the 2n to n plus 1 over n plus 1 or n plus 2 factorial. And then divided by the original series, or multiplied by the reciprocal of that original series, so n plus 1 factorial and x minus 1 to the 2n. Everybody good with that? Yeah? People at home good with that? And that should become the limit as n approaches infinity of an n plus 2 in the denominator and an x minus 1 squared in the numerator. And as n goes towards infinity, that should become 0, which tells us that our interval of convergence is negative infinity to infinity. Good or no? That was worth 3 points. 1 for setting up the ratio, 1 for getting the limit, 1 for the interval. Any issues with that one? All right, and part D, we want to use the Taylor series for f around x equals 1 to determine whether f has any points of inflection. So what are we going to need to do for that? Yeah, if we're using f and we want to find points of inflection, we're going to need to take a second derivative. So first off, what's f prime going to be? Looks like that's going to be just x minus 1. And then for f, right? Yeah. So that should become 4, 6, so 2/3 of x minus 1 cubed. We'll just, maybe we'll do one more. What was the next one after that one? 6, so 1/4 x minus 1 to the 5th. And then we take our second derivative. What do we get? We get 1 plus, and then this one will become 2 times x minus 1 squared. This one will become 5/4 of x minus 1 to the 4th. And what are we going to notice about each of these? Yeah, the powers are all even. So what does that tell you about f double prime? It's always greater than or equal to 0. And so therefore it's always concave up, so no points of inflection. Good or no? Yeah. Zoom people, you good with that or no?
Good.
Great. Let's do another one. All right, so for part A, we want to find the interval of convergence for this power series. And so the first thing that we'll note about this is what? What is the first thing that we'll note about this? It's a geometric series, just like the one that was on the AP test yesterday, right? Yeah. Oh, did they? This one they don't. They told you it was geometric in there? Oh, that's nice. So what is the common ratio here between each term? Ratio is x plus 1, which tells us that as long as, the interval. So as long as x plus 1, or the absolute value of x plus 1 is less than 1, that should be our interval. And so what does that give us? That gives us x is less than 0, greater than -2. Easy enough. That was worth, wow, that was worth 3 points. Apparently. I guess 1 if you identified it as geometric. So I guess we should write that it's geometric. Should give an explanation as to why. So it's geometric. Common ratio is x plus 1. So they give you 1 point for that, 1 point for this, and 1 point for this. Good? That makes sense. Part B. So this is we want to find the sum of the series for f. So how do we find the sum of the series for f? All we have to do is do our first term over 1 minus our common ratio. And what does that give us? It gives us negative 1 over x. They didn't ask us for a specific value, right? It was just that, yeah, just negative 1 over x. So 1 point for that. Good? All right, part C. Let's see, we have, this sounds like it's very similar to the one you guys did yesterday, huh? We had to do an integral? Yeah. So g is the integral from negative 1 to x of f of t. We want to find g of negative 1/2. So g of x is the integral. What is it from negative 1 to x of x? And what are we looking for? G of, what was it? G of negative 1/2. All right. So in order to do that, all we really need to do is we were given the function, right? So our function was f of x is negative 1 over x. So this is just the integral from negative 1 to negative 1/2 of the natural of negative 1 over x dx, which is negative natural log x to the value of x from negative 1 to negative 1/2. It was negative 1/2, right? Negative 1/2. Yeah. And so we just end up with negative natural log of 1/2 minus negative natural log of 1. Obviously, that whole second part goes away. Negative natural log of 1/2 is a good answer. Or a better answer would be natural log of 2. Good? That was worth 2 points. 1 for the correct antiderivative, 1 for the correct answer. Part D. H is f of x squared minus 1. Write the first 3 non-zero terms and the general term. So what's our first term going to be? First term should be still 1. Second term should be, let's see, x plus 1. So we're going to replace the x plus 1 with x squared minus 1. So just x squared. Third general term should be just x squared squared. So x to the 4th. Didn't ask for a general term and a general term. So we just replace that. That should just be x squared to the n, or x to the 2n. And they said evaluate that at h of a half, right? So h of a half, well, we'll need to recognize it since we just said this is f of x squared minus 1. So we'll just figure out what that is. That's f of negative 3/4. And f of x was negative 1 over x. So negative 1 over negative 3/4. That would be a positive 4/3. And that was worth 3 points. 1 for the terms, 1 for the general term, 1 for the answer. Good or no? Wonderful. Cool. How are we feeling about this? People that still need to take a test on the 9th. You want to do another one, or?
Sure.
All right. How about this one? Does that seem like a good one? Great. It'll be that one. Ready?